In this lesson, we are going to introduce this idea of summation, and we use the sigma notation to represent summation, which just means we're going to add a bunch of pieces together. And so within this, we have this k equals 0, so that k is going to match our variable, like k, and so we could use a different letter for it. We'll get to it in a second. So this value right here represents your lower limit. All right, so you're going to go from 1 to 10, which is going to be your upper limit. So you have a formula or you have something that you're doing, and we are just going to add a bunch of values. So if it's just k, we're basically going to plug in 1, we're going to plug in 2, we're going to plug in 3, we're going to plug in 4, plug in 5, plug in 6, plug in 7, plug in 8, plug in 9, and plug in 10. And that's the idea. Now, if this was a formula, then you would be doing things and getting different values than this, but we didn't have a formula, so nothing's changing on it. But basically, we're going to be plugging in values from 1 to 10, and we're going to add them together. That's the summation idea. So if you add all this together, your sum on this would be 55. And so different formulas are going to have different things. If you're going to go 1 to n, you're going to do a 1 plus 2 plus 3 plus ... plus n, and you can't write out a final answer on that because you don't know where it ends. And so that would be representing your answer. And then here, same idea as this, but now you actually have a formula that you're plugging in. So you're starting with 0 and you're squaring it, plus 1 squared, plus 2 squared, plus 3 squared. And so then you'd have a 0 plus the 1, 0 plus 1 plus 4 plus 9. So that sum is going to give us 14. So that's the basic idea of a summation. And this variable is a k on every one of these, but really it doesn't matter. You can have an n, and then you'd see an n equals 1. You're starting at 1. If it's p, then you're going to see p equals 1. It's really just kind of it's called the index. It's just a dummy variable. It can be really anything. So this could get out of hand very quickly, though. We're only going from 0 to 10, and we're at quite a bit of pieces together. So if we went from, not 0 to 10, but if we went from 1 to 10, if we went from 1 to 100, all of a sudden, this becomes kind of a pain. So luckily, people figured out that there were formulas to this, that if you're going from a 1 to 100, there's a little bit of a formula that will help your cause. And so we don't have to always necessarily do the math on this. There's shortcuts. So if you have a piece that's just a k, like a linear kind of piece, you have a quadratic-ish kind of piece, a cubic-ish kind of piece, you have these values. And then here, that c would represent a constant. See how it doesn't match? So you don't have a k value that's changing. You're just basically plugging in, like there's nothing that's happening to it. And so it's just the c value over and over and over and over and over again. You just have to figure out how many c values that you have that you're going to be adding together. And then it just becomes really a multiplication, because if that c value is 2 and you're doing 5 of them, you're going to have 2 plus 2 plus 2 plus 2, 5 of them. Shortcut to that constant addition is multiplication. So it would just be 2 times 5. So let's say we take this exact same first one and try to use it with a formula and see if we still get that 55. So if this is our idea, then we are going to use this formula because it's just kind of this linear piece. Our n is 10. 10 times 10 plus 1. And then that value is going to be divided by 2. And so we have a 10 times 11 divided by 2. This can simplify, and you're going to get a sum of 55. That is wonderful, because this can get out of hand very quickly. We're going to use this eventually because a Riemann sum is a sum of a bunch of values. And right now, we've only kind of broken things into maybe 4 subintervals or 6 subintervals, which is not a ton. And so it was easy for us to just find the areas of these individual rectangles. But what if suddenly this thing becomes 100? We want 100 small little tiny rectangles. I don't want to do this by hand. I need to find a better way. And so there is going to be a pattern to this where I can create some sort of an equation that's going to represent it. And with that equation then is going to have some shortcuts. that I can go ahead and plug this stuff into a calculator and help figure it out. So that's eventually what's happening, is we're going to connect this to Riemann sums, and we're going to have a lot of rectangles or a lot of values that we're going to add together. We're going to see if we can figure out some shortcuts to it.